Live from the Icebox Studio in Montgomeryville, Pennsylvania. It's the Bill and Corey Show. I'm Bill.
And I'm Corey.
Hey, welcome back to another episode. This is our 31st live episode. So I'm glad you could all join us. Of course, we have the YouTube chat set up. So if you have any questions, just type them right in. First question is going to be for Corey. Any suggestions as to the problem in having with recently purchased valve to add to the existing regulator? See message and attached images below. You don't need to tell that. Everybody's talking about valve. They're talking about the SEQ VLV 1482 SA, and it says the diaphragm valve, 1/4 inch female pipe thread inlet by long 1/4 inch outlet. And they wanted to put this on a regulator, and you'd have to have the inlet would have to be male pipe thread.
Yes, and as you can see, I'm holding two valves that look suspiciously similar. You could almost say they're the same, but they're not. As you can see, the flow arrows on these are different. Now, these are diaphragm valves, and a diaphragm valve can close either direction. However, there is a preferred direction because the pressure hitting the diaphragm valve helps keep the diaphragm closed. So it uses the pressure to keep it closed. So there's a preferred direction. And so when you put them on, you want to look at the arrows. They're very, very nice and clear. This one is long male outlet. This one is long male inlet.
Yeah, so the flow direction is actually kind of in the opposite direction.
Yeah.
And then, can you tell us about the other markings on the valve so you can help identify the valve?
Yes, actually, yes. So it has the part number right on the valve.
Yeah.
So if you need to, this one does not. This one does. they do normally have the part number on the valve, and then it also tells you max pressure and the material it is, because the brass is plated,
nickel
plated, so it could look stainless steel to people, so it'll say brass on it.
And you could have a Monell valve too.
And you could have a Monell valve too.
Yeah. And that would have Monell on it.
It would have Monell on it. Good question, Bill.
Okay, thank you. Next question's for me. I would like to know what the maximum helium leak rate is for a 2210 series pressure regulator. Okay, and this is a 2210 series pressure regulator. It's a miniature regulator. It's really kind of neat looking.
It's a dual stage too.
Dual stage regulator.
A small one.
And it's for applications for the laboratory. It's got low flow rates. It's got a small outlet fitting. So if you're in a tight bottle yard, you got a lot of bottles, and you don't have room for the bigger regulator like this, use a nice little small one here.
Lecture bottle?
This is you can use it for lecture bottles too, if you want a little dual stage. It's a nice little thing. You adjust the pressure up here. Little outlet. This is hose. We typically sell them hose barb, 1/8 inch female pipe thread, or 1/8 inch compression fitting. I think is what we sell on there. And the leak test on this, for this one, we do a nitrogen bubble leak test with a soapy solution, and we have special soaps solution here. You can buy soapy solution in our online store called Bubble.
Not to be used in the shower.
No,
it's not gonna clean it very well.
Unless you're really small. And then so we would do some regulators we do nitrogen bubble leak test. This is one of them. We do the nitrogen bubble leak test on general purpose regulators, ones that have rubber type diaphragms, and like piston regulators. So this is a piston regulator, has O-ring seal. So we do just a bubble leak test on it. CJE 14 defines bubble tight as a water immersion test at 1 × 10⁵ cc's per second of nitrogen. And that's like saying, you snoop it up, and after a while you don't see any bubbles, and it passes the test. So that would be equivalent for helium. That'd be equivalent to about 3 × 10⁵ cc's per second of helium. And then we have, for other leak tests that we do, a regulator like this, we would pressurize this with helium, and so it'd be pressurized with helium, and then we have a leak detector that would go around, and we probe the areas where you could be leaks around the pipe threads, around the gauges.
Sniffs for helium.
Yeah, and then check to make sure it doesn't leak out the outlet. And that leak standard for a bar stock regulator stainless steel diaphragms would be 1 × 10⁻⁵ cc's per second using the helium leak detector. Now, if you get really fancy, there are semiconductor. We don't have a semiconductor grade regulator here.
No, not really.
But we've got regulators that are welded and VCR connections, no pipe threads on them. And we do an inboard leak test. So we pull we have a special machine, pulls a vacuum on it. And we pull a vacuum on it, and then we sniff. What we would do is spray helium around the pipe threads and see if the vacuum pulls it in and it detects the helium. And that's 2 × 10⁻⁸ cc's per second. And if you do that, I think if my math's correct, that is about that leak rate, 2 × 10⁻⁸ cc's per second of helium. That's equivalent to about 1 cc helium leak in a 1.5 years.
Wow.
So that's a long time. Now we can offer certified leak tests, either the outboard 1 × 10⁻⁵ cc's per second for your stainless steel diaphragm regulators, or we can also offer the inboard leak test, and we could do that on this kind of regulator, the pipe thread connections with stainless steel diaphragms. We could do a certified leak test on that.
And these ones will even pass.
Yeah. But if you're doing a general purpose regulator with a rubber diaphragm, that's
not going to pass.
That's not going to pass. So don't even bother asking for that. And okay, so I think we covered all the leak test stuff on there. Next question is for Corey.
I'll just pick up a regulator.
Yeah, you can pick up the regulator.
Yeah, it's a regulator.
So I'm looking to design an RV relief valve, not a recreational vehicle. Not a recreational vehicle, based on a regulator failure. And we get this question now and then. Do you recommend using typical flow as the max flow? And if so, is the 100 psi delivery flow a delta flow, as in for every 100 psi DP for the 3510A, there's an 8 CFM N2 flow? I'm not sure exactly what you're
talking about, but it really, unfortunately, does not matter, because do not use flow curves to size relief valves. You need to use the CVs of them for valve sizing. And the CV is the full open sizing. It's the flow coefficient, and it specifies the amount of water at 60 degrees F, gallons per minute, that will flow through a valve and produce a 1 psi pressure drop. Yes, I was reading that.
Yes. And we don't, people typically don't flow a gallon of water through the regulator.
No, they don't.
Happens. They check orifice size. They do some calculations on that.
But it's based. The calculations are based on that. And so so the CV of when it fails is what you want to know. The flow curves, though, they only show how it flows depending on the inlet pressure versus the outlet pressure, because that is what
flip-flopped.
Oh, that's right, because I got to look at it this way, but it doesn't help you. So
inlet, outlet.
Inlet, outlet. So the inlet pressure to the outlet pressure, yes. And so that's the flow rate is based off of the difference in pressure, essentially. And so that's all it's going to show you about that is
and one of the reasons why you can't use that is the fact that when you're doing the full C sub V is when the regulator is cranked in all the way and the valve's totally open.
Yeah.
But when you have it at a lower pressure, you're backing it out, and you don't have it fully open. So your CV will actually change, and you can't calculate that. So that's one of the reasons why you do that.
Does it even reach full CV, fully open? I thought.
That's what they use for that's what you use for failure flow.
Okay.
And it's a way of giving you an idea, comparing regulators.
Okay.
If you have a CV of 1, it's going to flow more than a CV of 0.1.
Yeah, so this one, I think, what is it, 0.13 CV?
Yeah, that's what 0.1.
Yeah, it's a really small CV.
Now, we do have, on our outline drawings and in online store, we'll have a typical flow rate.
Yes.
And that's because people have that question. We put that up there because there's varying flow rates depending on your pressure. And we figured that was a way that people could kind of identify, kind of the pressure flow range. Like some of these might be rated like 8 CFM, that's your typical flow rate. You look at that and go, okay, so it can kind of flow that. And if you say, no, I really need something higher, then you might look at another one and might say 15 CFM flow rate. And you go, okay, got it. That's, if I need the higher flow rate, this is the one that's going to give me around that kind of flow rate.
And we have our CVs listed on our store.mathesongas.com, and you can look up all that information.
Yeah. Okay. Last question is on. Is going to be. We have a question. We're going to put up a graphic on our hard hat cabinet.
You want to reveal it?
Yeah. The question is.
It's a hard hat for a hard hat cabinet.
Well, it's really not that hard, but
it's metal.
I'll explain our hard hat cabinet. We sell our regular flat top cabinets. The hard hat cabinet is one that's supposed to be used outdoors. They wanted to have something. You see, there's exhaust stack on top, and obviously, if you're outdoors, you don't want to have rain come in that. And they were asking about having it capped off.
Squirrels dropping acorns down the hole.
Yeah, you don't want to have. No. Could probably. Anyway.
Well, I mean, they might.
But when we sell a hard hat cabinet, we sell a little rain hat you stick on top. This is for a 1-cylinder cabinet. It'll fit around the exhaust stack, and it'll keep the rain out, and it'll let any gases in there escape. Because sometimes the hard hat cabinets don't have ventilation system to it, so it's outside. So that's why we supply the rain hat. Now, how the hard hat cabinets differ from the regular cabinets is that we offered a rain hat and covered a stack. Oh, you can come back and show. I don't know if you're showing us now or you're showing the graphic. Showing us, okay. It has a rain hat. So a regular cabinet doesn't have a rain hat. So the hard hat will have a rain hat. It has a rain gutter in the front above the cabinet door to prevent rain from entering the cabinet.
So are you saying the hard hat cabinet is for outdoor purposes?
Yeah,
typically?
It's an outdoor purpose one. Oh, we do get people ordered for indoor use, but whatever. And it also has stainless steel hinges and hardware, because if you use carbon steel, that's kind of where the paint's going to get rubbed away. So we used a stainless steel hinges, so less likely to rust.
Yep.
So that the hardware and the little access door and the air intake at the bottom. And then we have, for the paint, we have a special zinc chromate primer to prevent rust and corrosion.
Aren't rust and corrosion the same thing?
No, it's actually a little different. Rust would be it's iron
a form
oxide.
I know, but isn't it a form of corrosion?
Yeah, you could just. This is marketing stuff.
Okay,
You probably just said corrosion. It's really.
Okay, all right. That's what I mean.
I don't know why you have it. It's marketing stuff.
I know. That's just
corrosion. Yeah. Because it's steel, so it's going to rust.
Yeah. It's
like aluminum will corrode.
It's like saying to prevent dogs and German shepherds.
Yeah, something like that. Yeah, so, that too. But we have marketing stuff. They always like putting that extra little